Hello, am I audible?
Yes, ma'am.
Okay. Okay, so last class we have been discussing about the coagulation sedimentation process, that is sedimentation aided with coagulation. So in today's class we will be discussing what are the constituents of a coagulation sedimentation plant. Okay, so this coagulation sedimentation process, it involves certain chemicals as we have learned in the last class. So here basically there is a coagulation sedimentation plant basically, so where the coagulation process it takes place. Okay, and this coagulation sedimentation plant, it is also sometimes known as coagulation plant, or also it is termed as a clariflocculator. Okay, so this clariflocculator, it has a 4 unit. So the first unit is your feeding device, then comes your mixing device, or also known as your mixing basin, then comes your flocculation tank or your flocculator, then comes your settling or your sedimentation tank. Okay, so these are the four constituents, or you can say the four parts of a coagulation sedimentation plant or a clariflocculator. So basically here, in the diagram you can see this is a clariflocculator. Okay, it is shown in a horizontal direction. So you can see here. So here basically the first stage, okay, the first stage of this clariflocculator is that you have to add the chemical coagulant to the clariflocculator in the first constituent, that is, or in the first part, that is your feeding device. So in the feeding device, the chemical coagulant, it is added, okay, in the feeding device. Either it is added in a dry form or it is added in a solution form, okay, into the raw water. So the chemical coagulant is added either in a dry form or in a solution form to the raw water in the feeding device, okay, through the feeding device. So this then when you after you add the chemical coagulant, so this mixture, it is thoroughly mixed. It is very thoroughly mixed, and as a result of this thoroughly mixture, and it is mixed in the mixing basin. So in the second part, that is in the mixing basin, this mixture, it is the mixture that is of the chemical coagulant and the raw water. These are thoroughly mixed, and it is in the mixing basin, and as a result, what is formed? As a result, a flock is formed. Okay, so flock, we have already learned what is a flock in the last class. So this flock, it is formed as a result of what? It is formed as a result of this chemical reaction which takes place between the chemical coagulant and the water. So this flock is it is formed in the mixing basin, and this flock, it is allowed to consolidate, or it is allowed to stay in the flocculation tank. Okay, then after the flock is formed, this flocculated water, it is finally it is passed to the sedimentation tank. It is there is a tank. The next step, it is passed to the sedimentation tank, and in this tank, this flocculated particles, they are allowed to settle down. Okay, they are allowed to settle down, and after they settle down, after a certain detention period, so what is done? This flocculated particles, it can be removed. Okay, so now the resultant water, now whatever, after removing the flocculated particle, the resultant water is now a clear water with you can say not that much clear, but it has a low turbidity, you can say. Okay, so after the resultant water, it has a low turbidity. It can be finally it can be taken out through this sedimentation tank's outlet, and directly it can be sent to the next step, that is your filtration process. Okay, and this complete process of this coagulation sedimentation, it is helping in removing the turbidity to almost, you can say, 10 to 20 milligram per liter. Okay, so the main thing is here in the this Clariflocculator is that here the whole process of mixing or the whole after how you are adding the coagulants or the chemicals, so it is done here in the Clariflocculator. So this Clariflocculator part, so each of the Clariflocculator part, that is what is a feeding for a feeding device, that is in the feeding device you can there is what dry feeding and there is a wet feeding. So in the dry feeding you just add the chemical coagulant directly in a powdered form, or either you can in the solution form, that is like you just add water with you add water at first, then you mix it, then you fed it into the this one wet feeding. Okay, so wet feeding, this wet feeding is, it is certainly it is a little bit costlier than this dry feeding equipments. Okay, but this the wet feeding, it has a little bit of advantages, that it can be the whole process, it can be controlled and it can be adjusted. Okay, so that is a advantage of your wet feeding. So these feeding devices, it's all about like how you are feeding the chemical coagulant in the this mixer feeding device. So this is all about, this one you will study by yourself. Okay, this wet feeding, everything is written here, the dry feeding and wet feeding, how it is done. So everything is written here, this one you will study, you go through once. Okay, then in the mixing basin, as I already told that here the after you add the coagulants to this water, then the mixture, it is thoroughly it is mixed, and thoroughly also it is very vigorously mixed, so that it is mixed in such a way so that the flock, it should it should form a flock. Okay, so the coagulant, whatever coagulant you have added in the water, so it should be dispersed into the entire mass of the you can say that this it disperse into the entire mass of the water. Okay, so this due to this violent agitation of this water, so it can why the mixing in the mixing basin, so the flock is formed. So in the mixing basin, the mixing basins can be of your two types. Okay, or there are two types of mixing basins, you can say. So the number one mixing basin is your baffle walls, and the mixing basin, it has a baffle wall, and the other one is a mixing basin equipped with some mechanical devices. So here in this picture you can see that here this one is a mixing basin with a baffle type. Okay, so these baffles are there, baffles are walls, you can say. This is a mixing basin, so these are the walls in a opposite direction. Okay, why these are put in a opposite direction? So this is the baffles are provided in such a way that the water, whenever the water flows in a horizontal direction around these ends, okay, so the water that is moving over these baffle walls, the water gets mixed thoroughly. Okay, so these mixing basins are, or mixing baffles are provided in such a way. Okay, so this is about your like, just a bit. Okay, so this mixing basins is the main function of the mixing basins I have discussed. Okay, so next is your like the flocculation tank. So the flocculation tank or the flocculator, basically it is it is a flock. Here, the best flock it will form when the mixture of the water and the coagulant are violently agitated, followed by a relatively slow and gentle stirring to permit buildup and agglomeration of the flock particles. That means here the the mixture of the water and the chemical coagulant, these are very much violently, or these are mixed. Okay, so that in also in a very slow and a gentle stirring is given, so that there is agglomeration of the flock particles, and as a result the flock is formed in the mixing basin. So this is the main work of this flocculation tank, or it is to form a flock. Okay, so this is the main work of the flocculation tank. So next is your okay, so this one you go through once about this each of this device. Okay, you go through once for each of this device. So next is your filtration. So the next step is your filtration. So the filtration here, after you have added the coagulants to the water, so here the filtration, the screening and sedimentation, that it is removing the suspended particles or the suspended solids and the organic matter that is present in the raw supplies. So here again, here in the this water, the process, that is the resultant water, it will, after all the treatments are however it is given, but this water, it will not be free from impurities, and it may contain very very fine suspended particles also. After doing the coagulation treatment also, the water, it will contain very much of very fine suspended particles. So here, and the bacteria are present in the water. So when you have to remove or reduce the remaining impurities whichever are present in the water. So this you have to remove the bacteria and all that is present in the water, so that you make the water a very drinkable water, so that you can drink. So you have to make the water pure. So we do the filtration process so that the bacteria can be removed, and also the very very fine suspended particles. Well, either it can be a discrete particle, or either it can be a flocculated particle, so those can be removed. Okay, so the process of passing the water through the beds of such granular materials is known as filtration. So filtration, the process, it is passing through a beds of such granular materials. That means in the process of filtration, so there are granules. Okay, so those are acting as a filter. So this process of passing the water through the beds of such granular materials, it is known as your filtration. So basically this filtration, it may help in removing the color, odor, or you can say turbidity, or some pathogenic bacteria that are present in the water. Okay, so there are, again, now in the filtration process, there are two types of filters, you can say. There are two types of filters. The first filter is your slow sand gravity filter, and the other one is the rapid sand gravity filter. Okay, so slow sand gravity filter is there, and the rapid sand gravity filter is there. So besides these two, there is another one, that is your a third type of rapid sand gravity filters is also there, that is working under pressure, and this is known as your pressure filter. Okay, so these two filters we will discuss it now. So first of all, let us know what are the filter materials that we use. So like we use sand. Okay, we use sand. Either the sand, it can be a fine sand or it can be a coarse sand. So the layers of sand, it may be supported on gravel. So gravel is there at the below. So which permits the filtered water to move freely to the under drains. So here, first of all, sand is used. So this filter sand, it has some of the properties. It has some properties. So what are those properties? That the sand, it should be free from dirt and other impurities. Then the sand, it should be uniform in nature, and it should be uniform in size. Then the sand, it should be hard and it should be resistant. Okay, then it should be such as not to lose more than 5% of its weight after being placed in hydrochloric acid for 24 hours. That means if you put the sand in hydrochloric acid for 24 hours, then it should not lose more than 5% of its weight. Okay, so that these are the four properties of a sand that is used in a filter media. So here, again for the gravel, we have like the gravel, that is used below the sand, it should be very hard. Okay, it should be durable. Then it should be also free from impurities. Then it should be properly rounded. Then it should have a density of about 1600 kg per meter cube. Okay, so that these gravels, it should be hard, durable, and also it should be free from impurities, and also it should be properly rounded, and it should have a density of about 1600 kg per meter cube. Okay, so the gravels of different sizes are usually used in 3-4 layers. So 3-4 layers are given, and the sizes of the gravels are of different sizes. Okay, and each of 15 to 20 centimeter. So the depth how the gravels are placed. That is, the gravels are placed in such a way that the coarsest gravel, it is placed in the bottommost layer, and the finest gravel, that is the size is up to, you can say, 3 to 6 millimeter, it is placed in the topmost layer. Okay, so that is about the gravel. Then these are about the, the materials that you are using. The main materials are the sand and the gravel. Then there are some other materials are also there, like anthrafilt is used as a filter media. Okay, so like this, different materials are there, but the main materials are only your sand and the gravel. Okay, then the next we will learn about the types of filters and their classifications. So basically there are the types of filters are the slow sand filters, rapid gravity filters, and the pressure filters. Okay, so filters, three types of filters we will learn. Okay, so the slow sand filters, actually these are nowadays not these has become nowadays obsolete. Okay, so the use has it has preferred, it is, these slow sand filters are preferred basically in a, you can say, in a, smaller plant, where there is a, in warm places there are smaller plants where, the covers of on filters are not required to protect the filters from freezing. So all these like these slow sand filters, since it gives a very slow rate of filtration, so nowadays these slow sand filters are not generally used. But and also these slow sand filters, it, requires a very large area for its installment. So nowadays we need a compact type of filter plant. So nowadays these slow sand filters are not used, since it also gives a very slow rate of filtration. And but the one thing is that the rapid gravity filters and slow sand filters, these slow sand filters gives a very appropriate, or you can say gives a more purified water. Okay, but though it gives a very slow rate of filtration, and also it requires a very large area for its installment. So these slow sand filters have nowadays becomes obsolete, and these are not used nowadays. Okay, so this slow sand filters construction process, I will not go through this construction process how this is made. So this one also you go through by yourself. Okay, this one you can see the diagram and what things are put, or how it is constructed. You can go through this slow construction of this slow sand filter, and also the construction of a rapid sand filter, you go through yourself. Okay, how the gravels are put, how the sands are put, what is the breadth of the, what is the depth, what is the height. So all these things you go through this part, and you will know. Okay, what is the base material given, what is, how is the under drainage system is provided, or how is the inlet and outlet arrangements are given. Okay, so all these things are written here nicely. So you just go through once about the construction of the slow sand filters. So next is your there is one numerical. We will go through this numerical, and do rapid sand filters we will go in the next class. Okay, so here design 6 slow sand filter beds from the following data. So what are the data given? That is, population to be served is 50,000 persons. Then per capita demand is 150 liters per head per day. Then rate of filtration is given as 180 liters per hour per square meter. Then your length of the bed is given as twice the breadth. Then the assume maximum demand as 1.8 times the average daily demand, and also assume the 1 unit out of 6 will be kept as standby. So here you are given to design a six slow sand filters. So among the 6 slow sand filters, 1 unit, okay, 1 unit out of the 6 units will be kept as standby. Okay, so if 1 unit, it becomes problematic, then other 6 units or other 5 units will work. So there are like 6 units you will design, but 1 unit is kept as a standby here. Okay, so among the data that are given here, so you can see, and you have learned in the first class about this average daily demand or this maximum daily demand, you have learned. Okay, so here population first thing we have to design. So we need the length, breadth, and width of the this filters, isn't it? So for finding out the length, breadth, and width, we need the area. So for finding the area, we need the surface area. Okay, for finding the surface area, we need the average daily demand or maximum daily demand we need. So the maximum, for finding the maximum daily demand, first you need the average daily demand. Okay, so find the average daily demand. We have the formula, that is your population by per capita demand. Okay, population multiplied by per capita demand. This formula already you got in the first class. So population is given as 50,000 and per capita demand is given as 150 liters per day. Okay, so you just multiply both and you will get 7.5 into 10 to the power 6 liters per day. So here, after finding the average daily demand, what is the formula for maximum daily demand? Maximum daily demand, that is MDD, is equal to 1.8 times of average daily demand. Okay, so 1.8 times of average daily demand, that is average daily demand. Now just now you got, that is 7.5 into 10 to the power 6, that is you just multiply 1.8 into 7.5 into 10 to the power 6, so you are getting a value, that is 13.5 into 10 to the power 6 liters per day. Okay, so maximum daily demand you have got. Now it is given to you that the rate of filtration is given, that is 180 liters per hour per square meter, but we don't need it in hours, we need it in day, since the other units are also in day. So since here 180 liters per hour is given, so you just convert it to per day, that is your 180 multiplied by 24. Okay, if you multiply it by 24, you will get it in days. So rate of filtration you have got. Okay, now you need the a to find the area. So first you can find out the total surface area of the filters. So how can you find out the total surface area of the filters? Just you divide the maximum daily demand by rate of the filtration per day. So both the values you have got, and you have finally got the total surface area. Now total surface you have got, but we need the area for each filter unit. Okay, we need the area for each filter unit. How will you find out the area for each filter unit? Since there are six you are told to find design six filter units, but there one unit is told to keep it as standby. Okay, for working performance later, so it is told to keep as standby. So you will find the filter unit area for filter unit of 5 units. Okay, so there are five, now total is five filter units are there. So you now find out the area for each unit. Okay, so total surface area you have, just divided by 5. Okay, if you divide it by 5, you will get the surface area for each unit. Okay, so the area for each filter unit is your 625 square meter. Now you got the area for each filter unit. So now we know that length is equal to twice b, that is given in the question. Okay, so in the question, the length of each bed is equal to twice the breadth. So L is equal to twice B, that is given to you. So now just you use this condition, L is equal to twice B. That is, we know that area is equal to length into breadth. Okay, so length into breadth is equal to 625 here. Area is what? Length into breadth is equal to 625. So length, what is given? Length is equal to twice B, it is given. So twice B, they have put it here twice B, and you just find it out, the B. B, it is 18 meter they got, and again L, you put the B value here, L is equal to twice B, so you will get the value for L. So like this, the whole numerically solved. So you got the length and breadth of the each filter units. Okay, so you are using a 6 filter units. Okay, so where the one unit or one filter unit will be kept as standby, and each unit of size 36 meter by 18 meter. Okay, so this is your slow sand filter, a very easy numerical. Okay, I hope you have understood. So next class we will go to the next your this one part, that is your rapids and gravity filters. Okay, rapids and gravity filters we will learn. So this one I will share to you by today. You please go through the construction of the slow sand filters. Okay, and also you go through the coagulation sedimentation, constituents of the coagulation sedimentation plant, you go through by yourself. Okay, not that tough, it is easy. So you just go through, you study once and you will understand. Okay, and if you don't understand, then you can ask me later. Okay, everyone. So thank you for today. You may leave the class now.